All right? And it's made up of monitoring, both manual and automated monitoring, visual inspections, and checking and testing. So what is that testing and checking? That's not testing and checking your monitoring results. That's actually testing and checking things like your mechanical equipment, your electrical equipment. All right. All that together is surveillance. All right. And you have to design it. You have to make provision. I'll show you guys now. You have to actually, in your design, make provision that you can do proper inspections, please. Some examples, and we'll even see tomorrow when we go out to site. Or I'll show you, make you aware about it. Okay, but please, if you can, use this terminology. All right. So let's quickly look at visual inspections. When you're busy, especially with your design of the dam. All right? Design for proper visual inspections. One of my pet hates, I get to a new dam. If I say new dam for me, but the dam has been there for 50 years. All right? No, it's an embankment dam. No chain leach markers on the crest. The dam is 600 meters long. I want to do a visual inspection. How, if I see something wrong on the crest or on the slope, how do I know where I am if I don't have chain leach markers on the crest? Okay? Very, very important. It's something that you guys must please put into your design. I know, well, in my world that I live in Southern Africa, those things normally get stolen if the public have access to the dam. But there's some solutions that you can think of how doing. Even when you have concrete, your concrete dams should have visible block numbering. Even on the outside. So if you look at it that you can see, I have a new seepage point at block number 10. And you should number the blocks. Because remember, I'm going back to my concept of knowledge management before. Okay? That I was talking about. We try inspections and monitoring as part of this collecting knowledge over the long term. So if I now go and do an inspection, and you come in 40 years' time, I no longer live. And you want to know, you read my report, but I said there was some seepage, but I don't have any proper signage. How would you know in 40 years' time where that seepage actually took place? Okay. So very important to actually design for proper inspections. Doesn't cost a lot of money. All right. Then the other thing, you have to design for vegetation management. I've seen it many times. People build a dam and then they keep the tree right alongside the embankment or the dam wall. We have the thing that at least the height of the dam, there must be no big trees, and you must do vegetation management away from the toe of the dam. Okay. So if you have a 100-meter high dam, you should really, okay, maybe that's extreme, but you should have it away from all your toe drains and things like that. Trees, notwithstanding all the issues that we discussed yesterday about trees, it also blocks things like toe drains and filter systems, the roots of it. Okay. And then to have proper access. We talked about it yesterday. Make sure, but let me show you quickly this example. It's a small arch dam in South Africa. All right. So to get to that side, the only way that you can get to that side is to actually go by boat and then climb up against rock there. There's no footpath to actually get there. But that's not the worst. Okay. You guys actually see this outlet structure. There is no door on the other side. So the only way that you actually can get there is to put the ladder here, climb over the roof and take the ladder and put it on the other side. This is an extreme case, but really please think about how the people are going to have to do the inspections in your design. Make provision for that. Most designers don't think about it, don't consider it. Really, please, really, when you do design, think how, if you had to go and do the inspection, what would you want to have? I've had my incidents in the past. Some of you guys that went with me, even when we did the previous training for NELSOP, I injured myself, my leg, trying to step over a railing. Okay. So please make it safe for the operating personnel. That's number one. So this is just an example of a chainage marker. So this dam actually have a road on it. They've put a railing to make sure that cars don't drive off the crest of the dam, and they've actually installed the chainage markers on the railing. This is just an example of a block numbering. This is Kohorobasa Dam. Everything is well signed. There's signage for everything, even the instruments. 2 weeks ago, I did the safety evaluation of a 110 meter high dam. And we got to an instrumentation installation, there's no signage. And the operating personnel could actually not tell me what instrument we were at. Okay. You can imagine that you can get confused if you actually go and do the measurements if it's not signed, if it's not properly signed, if I can put it that way. So you guys will see here, it's actually the instrument number, even the relative level, all right, and even the number in the database. Here you guys can see as well. And it was done during construction. All right. So I leave this with you guys. I'm not going to, as I say, talk more about design of instruments and so forth. But remember, every instrument in a project should be selected and placed to assist with answering a specific question. If there's no question, there should be no instrumentation. So don't copy and paste what you see being done at another dam. You have to think why. I always get this question when I do surveillance training. Somehow, especially in the beginning of the training, somebody raises his or her hand and say, how many piezometers do I need to place in my embankment? And then I ask them that question, because you need to answer that question yourself. Okay, when you do design. There's a lot of things that you can actually monitor. All right. So we monitor loads and we monitor structural responses. As I explained to somebody, if I do this and I put a load on this, the response is a movement. Okay. So those are the two concepts that we actually monitor. If we just look at the external loads, these are all the things that you can monitor. I'm not saying you should go and do that. All right. So the starting point, if you do design, and we've talked a bit about it yesterday as well, but definitely water level in your reservoir. Starting point. And if you actually put in a system where you can do basically semi-continuous monitoring, say every 5 to 10 minutes, that you get the value of your water level, it is nearly as good as a gauging station. All right, you can actually go and do calculations and determine your flood peaks that flow into your reservoir, and also the shape of your flood hydrograph. So really, you should, even if it's a small dam, consider water level. It doesn't cost a lot of money. Then temperature, you should consider the response parameters, but you need to answer that question that I was actually asking you. You need to have a question that you want answered to Alright. So if one actually look at monitoring, these are just some takeaway points. So you need to have proper safe access, appropriate solutions, these trigger points, alright, and then very, very important. In many cases, we can actually start our monitoring already during planning, especially the meteorological side. Alright, monitoring for me is not just the dam wall. It includes things like rainfall, river flow, because your flood hydrology is your major load on it. Okay, so if you can, you should actually already start monitoring that in planning if you have nothing. Alright, but then also during construction, I've seen so many times, big dams, they install the instruments, but they only start the monitoring after the construction is finished. Please, you have to, some of your biggest loads that you apply on a dam is during construction, especially a concrete dam, but the airfill as well. You need to monitor it during construction as well. Just an example, I said to you guys yesterday, Korabasa, very prime example how to do things. So here you guys can see this installation was done in 1972. Alright? It gets regularly painted. You guys can see it's got a protection. So there is it's still a Carlson instruments that I've sent in there that is very sensitive. They have lost, out of the more than 400 Carlson instruments that they have there, less than 10 are not working because they are very careful. But you guys can see each installation actually have the installation diagram there. So nobody is wondering what they should be doing, how it should look. Does any of your installations have something like that? Or going forward, you should think that you actually give attention and actually have installations that if you have a system where you actually have to plug into, that you can actually have a layout that people doing it knows what they're doing. Alright. Even there you guys can see provision made to actually put your instrument on there. Most dams, the instrument is there somewhere. The person that needs to take the reading must go on their knees or go and sit down and work in the ground. Are you going to get good measurements if the person is not, if they have to go and sit on the ground every time? No. So please make provision for an installation that you can actually put your readout unit there, that you can all write. I know it's a bit of a small increase in your cost, but over the long term you will actually get very good monitoring results. The other thing, so this is a manhole, and you're supposed to actually climb down there, and if there's seepage, to go and take a reading there. I can't fit in that manhole. I can't climb down there. Okay. So if you're doing designs, think about if persons. Okay, I'm taller than most people, but even an average sized person struggles to actually climb down there. So think about access to your monitoring points. Make it easy for the guys who, if you make it difficult, you will not get good monitoring results. Okay. Do you guys, let's break for tea time until 1:30, and then yeah, I've got a few.